Morning. Today we're doing 8-2 counting and probability. So the first thing we're going to go over is what a factorial is. A factorial is any positive integer n. We defined n factorial as n times n minus 1 times n minus 2 all the way down until we get to 3, 2, 1. So for example, 7 factorial would be 7 times 6 times 5 times 4 times 3 times 2 times 1. Now we can do this in the calculator. So the first thing we're going to do is enter the number. So I'm going to enter 7, and then I'm going to press the math key, and this screen will come up, and I'm going to move it over to where it says probability. You see right there I have that highlighted, and then I'm going to move the cursor down to the factorial button. It looks like an exclamation mark, and then we're going to press enter. The 7 factorial. Oh, sorry. Oops. Just in case you didn't see where the math key was, right here when I said press math, this is where the math key is located on your calculator. It's right under the alpha key. Okay, the multiplication counting principle. For a process involving multiple, let's say k, steps, there are n sub 1 ways to do step 1, n sub 2 ways to do step 2, n sub 3 ways to do step 3, so on and so forth, n sub k ways to do step k. Then the total number of different ways to complete the process is n1 times n2 times n3 times ... all the way to nk. So for example, the ice cream shop offers 28 flavors of ice cream, 11 different toppings, and 3 bowls for their sundaes. In how many ways can you order a sundae with 1 scoop of ice cream and 1 topping? So we're going to take the number of flavors, we're going to multiply by the number of toppings, and then we'll take the number of sizes and multiply. So 28 times 11 times 3 is 924 different ways I can order a 1 scoop sundae with 1 topping. How many ways are there to arrange 5 photographs on a single shelf? So options for picture 1 times options for picture 2 times the number of options for picture 3 times the number of options for picture 4 times the number of options for picture 5. So there's 5 pictures. So the first picture, there's 5 different pictures that I can choose from. Once I put that picture on the shelf, I only have 4 options left for picture 2. And then I've got 2 pictures on the shelf, so then I only have 3 options for picture 3, and so on and so forth. This would be 5 factorial, which is 120 ways to arrange the photographs. How many 3-character internet domain names are possible that consist of letters only? Okay, so we're going to do, there are 26 letters times 26 letters times 26 letters is 17,576 different domain names. Letters or numbers. Okay, so now we have to consider that there's 26 letters and 10 numbers. So there's 36 times 36 times 36, which is 46,656 different domain names. The picture to the right, there it is right there, shows New Jersey plates look like in 2 different years. If there are no restrictions on letters and numbers can be used in any position, assume numbers and letters must be in the positions shown. How many different license plates are possible in 1959 and then in 1999? So let's do 59 first. So if we look over here at 1959, I have a letter, a letter, a letter, a number, a number, a number. So I'm going to do number of letter options times number of letters times number of letters times number of numbers times number of numbers times number of numbers. So there's 26 letters, so we're going to do that 3 times. And then there's 10 numbers, so we're going to do that 3 times. Gives me a total of 17,576,000 license plates. In 1999, so I still have letter, 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 number, number, but the last one is now a letter. So we still have letters times letters times letters, and then there's numbers, numbers, and then a letters. So that's 26 times 26 times 26 times 10 times 10 times 26, which will increase the number of license plates to 45,697,600 license plates. Okay, a permutation is an arrangement where the order of selection matters. So, for example, if I'm thinking of a number, let me just get a pen here. If I write down the number 1 and 2, if I pick the number 2 and then 1, are these two digit numbers different numbers? Yes, but they're made of the same digits, They're both made of 1 and 2, but the order that they're in matters. That's a permutation. Okay, so in general, the number of permutations of n things taken k at a time is given by the formula npk equals n factorial and then n minus k factorial. So if we look at this thing right here, it says number of permutations n taken k at a time. So this n is the total, and the k is how many we are choosing. Okay, so this is the total available, and the k is how many that we have to choose, like how many we're going to choose. So for example, each day the teacher chooses 3 class helpers from a class of 28 students. How many possibilities are there for who was drawn? So the first thing I'm thinking about is whether order matters, okay? So does the order that they're drawn matter? Yes, because there's different class helper positions. So if I'm drawn first, I might get to write on the board. If I'm drawn second, I might get to be line leader. Well, those are different positions, so the order that I'm drawn makes a difference, so the order matters. So we're looking at P. I'm drawing 3, so this 3 is going to be my K, and I have a class of 28 students, so that's going to be my N. Okay, so order matters. And then if I put this in place, NPK, the 28 goes on the left, the 3 goes on the right. And if I put that in the formula, 28 factorial over 28 minus 3 factorial will be 28 factorial over 25 factorial is equal to 19,656 possibilities. I'm going to show you how to do this in the calculator in a minute. Okay, combinations is when the order does not matter. So for example, if I choose 3 people to come with me to Disney World, if you're one of the people chosen, you get to go to Disney World. Does it matter whether you're chosen first or second? No, the outcome is still the same. You still get to come with me to Disney World. So the order doesn't matter because the outcome that you get is still the same. So in general, the number of combinations taken n things taken k at a time. So n is the total, k is how many we're taking, and ck is n factorial over k factorial times n minus k factorial. So for example, a teacher chooses 3 papers to grade from a class of 28 students. How many possibilities are there for papers were graded? So if I'm chosen, my paper gets graded. It doesn't matter whether I'm chosen first, second, or third, so order doesn't matter. I still get my paper graded if my paper is chosen. So this is going to be 28C3. The 28 goes on the left right here, and the 3 goes on the right. Plug it into the formula, and that's going to give me 3,276 possibilities. So let me show you how to use the calculator. And there is a video in the Google Classroom showing how to do this on the calculator. I'm just writing the steps out for you here. So the first thing we're going to do is enter the number, and then we're going to press math. The number that we're entering here is the total. So we're going to enter the total number. So this is my n. So we're going to enter my n. And then I'm going to press math. And then I'm going to move the cursor over to PRB. And I'm going to move the cursor down to either P or C. So here we go. Let me show you what I mean. So this is what comes up when I press math. The math key is right here under alpha. And then I'm moving it over to probability. And then right here, do you see the NPR? That's my P formula. And here is my C formula. So I would enter the 28 first, and then I would press math, cursor over to probability. I'd come down to the P, and that's what would come up. And then I'm going to enter that 3, and then I'm going to press enter. And it's going to give me my answer of 19,656. It kind of saves me from having to put it into the formula. So same thing with the C. I'm going to press the number that I want. So in this case, I put 28 first, and then I go over math down to C. That brings this up on the calculator. And then I enter the number 3. Now, my calculator is a little older. Some of the newer calculators, like the ones on your computers, will probably put this 28 in place of the N right here. It'll probably substitute it right in. That's okay. It's doing the exact same thing. And then press enter, and you got your answer. All right. So Can a spot be filled by the same individual as spot 2? If the answer is yes, then we're having repetition is allowed. If the answer, okay, hold on a second. Let me reword that. If I can have the same thing twice, then repetition is allowed, and we're going to use the multiplication counting principle. If I can't have the same thing twice, repetition is not allowed. Now I have to decide whether order matters. We're going to use P. If order does not matter, we're going to use C. Okay, so let's go and do an example. On the way home I can't read. On the way home, you decide to stop at 28 Choice Ice Cream Parlor for a snack. With 28 flavors to choose, how many ways are there to order? A cone with 2 scoops. So if I think about a cone, does it matter the order that they're in? Okay. All right, so let's think about this here for a second. And I actually asked the wrong question first. Can I have the same flavor twice? That's the first question I need to ask. Yes, I can have a cone with 2 scoops of the same ice cream. So repetition is allowed. That means we're going to use the counting principle. So I'm going to take the number of flavors and multiply by the number of flavors. There's 28 flavors to choose from, so I'm going to do 28 times 28. That's 787 ways to select a cone with 2 scoops. Now, a cone with different flavor scoops. Now repetition is not allowed. Okay, do you see the difference there? I can't have the same scoop twice because I need different flavors. Now, do I care about the order? Yes, it says I care about the order of flavors. So strawberry vanilla is a different ice cream cone than vanilla strawberry, so order matters. If order matters, we're going to use P. So now I have N, which is 28. I'm going to select 2 because I want 2 scoops, and I'm going to put that in the calculator, and that gives me 756 ways to select a cone with 2 flavor scoops. How about a cup with 2 flavor scoops? Okay, so it says different. So if it says different, that means repetition is not allowed. Now, order doesn't matter. So here, whether I have a purple and then a yellow, or a yellow and then a purple, it's still the same 2 scoops of ice cream in the cup. I can eat it in either order. Whereas here, the order is going to matter because the strawberry is on top, and that would mean I would eat that first. So since order does not matter, we're going to use C. So 28C2 is 378 ways to have 2 different flavor scoops in a cup. Now, what about a cup with 2 scoops? So here we go. A cup with 2 scoops, the order still doesn't matter, right? So I'm still using C, but now I can have the same scoop, right? So repetition is allowed, but order still doesn't matter. So I'm still going to do my C, but then I have to add in the 28 different ways I can have the same scoop of ice cream twice. So that's going to be 406 ways that I can have a cup with 2 scoops. Okay, practice problems. These are the pages I used to create the Google form. I believe, if I'm not mistaken, I made this one multiple choice. Guys, have a good day. Email me if you have any questions. Bye.